The widespread acceptance of remote manipulator technology as an alternative to human exposure in hazardous environments has proven itself to be a technology worthwhile to man. In this presentation, we will see the products of a company that have given us the most advanced and field-proven telerobotics technology today. In 1981, Kraft Telerobotics introduced the GRIPS manipulator. This system is a highly advanced, teleoperated robotic arm which closely approximates the human arm in design. Drawing on the knowledge gained through the application of the GRIPS system and a desire to further improve the technology, Kraft in 1983 committed its resources to the development of a manipulator that was bilateral and force reflecting. In other words, Kraft has created a control system that gives the operator a direct sense of feel and a level of natural interaction as if the distant manipulator he is operating is an extension of his own arm. Now it is this development of bilateral force-reflecting control technology, above all Kraft achievements, that has catapulted Kraft into the position of a world leader of remotely controlled systems. Kraft produces telerobotic systems that have been developed to operate in a wide variety of unstructured environments. This variety will soon become evident as we move through this presentation. What makes the Kraft technology unique is that it embodies force feedback. What is force feedback? Well, when the distant manipulator encounters an object, the forces felt by the manipulator are fed back to the operator's arm through the master controller. This provides the operator with a physical and mental sense of feeling by allowing him to experience the motion and forces acting upon the distant manipulator. To demonstrate this, you can see how hard the operator is pushing on the controller when the manipulator comes up against the resistance of this weighted crate. It is as if his arm is trying to push the crate sideways. His arm is being stopped just as the manipulator is being stopped. The control system gives the operator the same resistance being felt by the manipulator. The manipulator system has more than enough force to move the crate, but because the control system will only let the operator push within his physical capability, the manipulator is doing exactly as he is directing it to do, with the same motion and force. It should be noted that this force information can be instantly modified through a hand terminal so that the operator's efforts can be amplified. This allows him to do a task which requires more power or can be used to reduce operator fatigue, and yet still give him a sense of feel. If the force information fed back to the operator's controller is deactivated, he can only control the position of the arm, and the manipulator moves to the new position using any power it has at its disposal. This is what you see now. The result is that the full unfelt power of the manipulator easily moves the heavily weighted crate. There are many circumstances where force feedback is desirable and even necessary. Without a real sense of how much force is being exerted by the manipulator, the operator could easily damage a work site, a workpiece, a tool, or, for that matter, the manipulator itself. The second goal of force feedback is to provide bilateral control. The term bilateral literally means two-sided. Either side of the manipulator system, the controller or the manipulator, can at any time, at any given moment, control the other. We have seen how the operator using the master controller directed the manipulator to move. Well, the reverse is also true. Here the manipulator is being moved, and it now is directing the controller to move or comply. What is the value of this capability? With this compliance occurring, the operator can easily trace contours or irregular shapes with the manipulator by allowing the master controls to adjust as needed, just as the operator is doing here with the contours of the crate. He does this with such ease that it is hard to imagine how difficult this would be without bilateral control. If he didn't have a bilateral control system working for him, he would have to rely totally on his sense of sight, and the process would be slow and jerky. Kraft's force feedback allows any user to perform complex work tasks without the benefit of special talent or intensive training. This is possible because of the intuitive nature of the control system. Force feedback also allows the user to perform all manipulator tasks more quickly and to perform tasks of much greater complexity. It reduces the risk of accidental damage to the worksite or the manipulator and allows the performance of tasks that may otherwise be impossible without the dimension of feeling and the compliant nature of a force feedback system. Although force feedback technology is not a new concept, its implementation in the past has not met realistic cost and operator fatigue requirements. These requirements have been achieved by Craft Telerobotics as a result of a 5-year development program. The GRIPS force feedback manipulator and other Craft work systems have several computer-enhanced capabilities which are included as standard features. All of these features can be quickly accessed by the use of the system's small hand terminal. Here are some of these features. The manipulator motion can be rescaled upward so that when the operator moves the controller, the manipulator or work system will follow as before, but with a much larger range of motion than the controller. We see this process being done here with a manipulator-sized backhoe excavator. This rescaling can be done to reduce operator fatigue or to allow the controller to use smaller motions to adapt to limited operator space. The scale of manipulator motion can also be reduced. This allows the operator to do much more precise work. When the operator makes gross movements, the manipulator then makes small ones. Some of the other computer-enhanced capabilities that are standard but not shown here are indexed motion and constrained motion. Indexed motion can be used to reduce operator fatigue. For example, if the operator wished to use the manipulator overhead for an extended period of time, his arm would quickly become fatigued from working in this position. The operator can re-index the controller so that he can use the controller in a much more comfortable horizontal position. Constrained motion is another valuable capability. This is the ability of the operator to establish boundaries outside of which the hydraulic system or manipulator will not pass, even if the operator moves his controller beyond these pre-specified boundaries. The constrained motion feature can prevent impact and damage to surrounding equipment or provide increased safety for the system and the operator. When this capability is used on the Craft backhoe excavator, it keeps the excavator's bucket away from overhead power lines and nearby structures. The operator can also teach the manipulator a work routine by moving it through a sequence he wishes it to learn. This teach playback capability allows the manipulator to automatically perform complex work sequences. If we watch the same arm that was programmed, we will see that the manipulator is playing back the same sequence. Notice that the operator's right-hand controller isn't moving. We have talked about Craft's unique control technology and seen the capabilities of the equipment, but now let's look at some of the fields where it is being applied. Craft Telerobotics' first systems were used in support of the offshore petroleum and gas industry. Craft had from the beginning an almost unreasonable attitude toward producing a quality product. But then, the hostile undersea environment is a formidable workplace. Craft manipulators were designed for the abusive workloads, corrosive environment, and limited access to technical support typical to the open sea. GRIPS manipulators were installed on undersea robotic free-swimming work vehicles. Because of capability and reliability, the system became an instant success. Craft then pushed the technology beyond traditional undersea work systems. Craft manipulators were the first to be able to clean undersea structural welds and perform non-destructive testing. In this procedure, the manipulator was instantly taught tasks on site to tailor the operation and reduce operator error and fatigue. A Craft manipulator was used on an undersea robot that assisted in the recovery operation of the Challenger shuttle. This was the first bridge to be drawn between Craft's technology in the undersea world and its later introduction to aerospace applications. Craft's development of force feedback technology has also made it possible for the electric utility industry to move toward cutting the tremendous cost of power outages on high-voltage transmission lines. Live line work on overhead transmission systems, such as this change out of an insulator string, is physically demanding and potentially lethal. Work must stop if lightning is present or imminent. Rain or other precipitation creates prohibitive electrical hazards, while high winds, bitter cold, or broiling sun can prevent a lineman from performing critical tasks. The result can be power outages with replacement energy costs exceeding thousands of dollars a minute. With the lineman operator located in the safety and comfort of an enclosed control van at ground level, the CRAFT system facilitates live line work under a variety of conditions which would make it difficult, unsafe, or impossible for crews to work. The CRAFT manipulator system has operated successfully in a high voltage field exceeding 1 million volts while demonstrating the ability to perform a variety of complex tasks on energized transmission lines. This use of CRAFT technology is also being applied in Japan. CRAFT Telerobotics has a product licensing agreement with Japan's leading manufacturer of special purpose vehicles and aerial lifts for Japan's domestic electric utility industry. The CRAFT manipulators in this application are integrated with an aerial lift truck. The use of CRAFT technology in Japan is focused on the installation, repair, and maintenance of street-level power distribution systems instead of high-tension transmission lines. The approach here, compared to the high-potential transmission line system seen earlier, is different. Instead of having the operator at a remote location on the ground, the operator here is at the work site. This provides direct viewing by the on-site operator while he is insulated from the work and the prevailing weather. The unique ability of the GRIPS manipulator to operate within a radiation-contaminated environment has provided a solution in the handling of hazardous waste and the decommissioning of aging nuclear facilities worldwide. CRAFT manipulators were chosen for the remote work vehicle Workhorse. The Workhorse is a mobile system designed for reconnaissance, recovery, and decontamination operations in radiological environments. This system has been used in support of the decontamination efforts in the 3 Mile Island Unit 2 nuclear facility for the past few years. Nuclear recovery robots must be capable of aggressive decontamination. The GRIPS manipulator represents a class of teleoperated robots that exhibit the strength and adaptability required for work in hostile and dynamic settings. GRIPS manipulators are used for a wide variety of tasks in the decontamination process. Removal of sediment, cutting with abrasive saws, package and transport of materials from contaminated areas, cleaning of surfaces by scarifying, applying surface treatments, cutting with high-pressure water, and removal of barriers by cutting, demolition, and removal of debris. CRAFT's technology has also become part of our space effort. NASA is moving forward on a program to reduce the amount of time the astronaut is required to work outside the unpressurized areas of the space station. This will be accomplished with a multi-purpose teleoperated system called the Flight Telerobotic Servicer, or FTS. The FTS will assist the astronaut in performing assembly, service, and inspection tasks. FTS project personnel understood that very few successful designs go from drawing board to production without some form of prototyping. The best baseline technology to use in any prototype is one which is the most advanced. The more work that has already been done by others, the less work has to be accomplished in the next stage of development. Manipulative tasks will be a large percentage of the FTS mission. As a result, the ambitious FTS development program must build upon the maturity of today's telerobotic manipulator technology. After a thorough investigation of telerobotic manipulator products, CRAFT technology was chosen by NASA to support the FTS program. CRAFT manipulator systems have been integrated into a 2-arm FTS simulator prototype at NASA's Goddard Space Flight Center. Here, NASA personnel are examining and evaluating state-of-the-art manipulator capability. Craft's force feedback manipulator system provides engineers and astronauts with hands-on experience under mock-up conditions. Craft's force reflection controllers have also been selected to interface with non-Craft manipulators at the Langley Research Center and in the Goddard Robotics Laboratory. Further research is being done by the University of Kansas for the Langley Research Center. The university is using a dual Craft system to investigate enhanced sensory capability. And the engineers at the Johnson Space Center in Texas also work with a Craft system in their laboratory. They are using Craft technology to evaluate leading-edge manipulator capability as it relates to human factors. The aerospace companies have also recognized Craft's technology. This system is providing their engineers with the biotechnology and instinctive control characteristics necessary for simultaneous two-arm operation. The compact size of Craft's controllers have enabled engineers to demonstrate the feasibility of master-slave manipulator control when operating within the confined spaces aboard the shuttle. So far, we have discussed Craft's bilateral force feedback control technology as it pertains to manipulators. This control technology has other applications for systems that also have been designed to simulate the capability of the human arm and hand, but on a much larger scale. Craft's HazTrack remotely controlled excavator is one of these systems. When you think about it, an excavator is like a large arm that has a shovel instead of a hand. What Craft's control technology supplies to this operation is the ability to replace all the control levers with one controller. A novice excavator operator must spend months before he becomes smooth and proficient with all the controls of the traditional excavator. If he is then required to operate an excavator manufactured by another company, the controls may be different. He then must come up to speed on that system. With all the capabilities of the Craft control system, the learning process is almost instantaneous when compared with other excavators out there today. If a person can control the movement of his or her own arm, this system is the answer. There is another, maybe more significant reason that the single controller system is better than multiple control levers. The HazTrack excavator can have an ability to dig under pipes and other objects, or contour an excavation in ways presently impossible, and then it can dig a trench tight up against a wall. These capabilities are only possible because two more functions, bucket yaw and bucket roll, can be added to the HazTrack shovel arm. With conventional control methods, more levers would have to be added, but this would overwhelm an operator because of the variety of control functions. On the other hand, the improved capability of bucket yaw and roll can still be controlled by a single Craft controller. There is another aspect of the HazTrack excavator. Both the arm functions and the track vehicle transport can be remotely controlled from a location that is a safe distance from hazardous environments. It is during this mode of operation that the intuitive nature of the Craft controller far surpasses multi-lever systems. This is particularly true when you add the dimension of bilateral force feedback. You remember the discussion of the ability to teach routines to the system and the ability to establish boundaries of safe movement? These and all other standard control features are available on the Craft excavator as well. Of course, this control technology is not just limited to commercial applications. Remotely operated excavators and other large hydraulically powered equipment are also required by the Department of Energy for the remote handling of chemical and nuclear wastes. And then there are the military applications. Mobile, remotely operated work vehicles are needed to assist in the clearing of ordnance and the repair of runways and other facilities. To sum it all up, Craft bilateral force feedback control technology is a solution for new applications and the answer to old limitations.